Guys, last time we met, we did exponents and surds, and we looked at the laws of exponents and surds, right? And hopefully we got an understanding of what these laws mean and what they entail. So today we can actually move on and do some problems related to the laws of exponents. All right, so we're going to look at simplification problems to start with. How to simplify what? We are simplifying here our exponents. Yes, exponents and our surds. That's what we are going to be doing for grade 11. Right, so welcome. It's been a long time, and yeah, it's been a minute, guys. It's been a minute. Just so people know, I will actually be having a lesson with the grade 12s this evening, tonight. I think grade 12, I'll have a lesson with you at just after 9, okay? 9 p.m. tonight. Yeah, we'll have a lesson then. We'll start off with the topic that is basically the first topic for grade 12, which is sequence and series. So tonight at 10. Okay, just banking on 9 p.m., 10 p.m. That's when we are banking. We'll have that lesson happening, all right? But today it's grade 11, continuation with grade 11 lesson, exponents and surds. We started it yesterday. We looked at just the laws of exponents because funny story is that, even though grade 12s don't do exponents and surds as a topic, but it will affect much of what they do in the coming year. So yeah, if you're a grade 12 learner and you are here, you can listen for as long as you feel like you need to, and then you are more than welcome to gravitate away from this live. But yeah, for as long as you want to, you can chill and listen and see, and just make sure that you are remembering all the things that you ought to be remembering as a grade 12 learner. So yesterday we looked at these guys. We looked at all the laws. Law number 1 of exponents, the fact that when we multiply same bases, we keep the base, we add the exponents. That was law number 1. Multiplication, the product of same bases, the addition of exponents. Law number 2, the quotient or the division of same bases means the difference of the exponents. All right, whether that is written with the division sign explicitly there or written as a fraction, we know that both divide and the line for a fraction mean division. So that means that the quotient of the bases leads to the difference of the exponents. Right, law number 3, we looked at how a base raised to a certain exponent raised to another exponent means that we multiply. It's the product of the exponents. Then law number 3 is further, you could say, supported by the idea that as long as we have different bases that are multiplied or divided, law number 3 can be applied for different bases with an exponent on the outside, as long as it is multiply between the bases or division between the bases. Then law number 3, with the exponent gets multiplied to each respective exponent for each base. The exponent gets multiplied to each respective base for division. But yesterday we clarified that this does not apply for addition and subtraction. We do not distribute the exponent by multiplication where there is a sum of bases and where there is a difference of bases. We clarified that that is nonsense to apply the exponent by multiplication for difference of bases and addition of bases. It does not apply. Law number 3 only applies for multiplication and division of bases, but law number 3 does not apply for the sum and the difference of bases. And that's something we clarified yesterday very strongly, Yeah. And I think the way that we resolved it was that with multiplication, we know that for bases, for multiplication, inside the bracket, this is one term. Inside this bracket, this is also referred to as one term, because multiply and divide actually combine terms, which is why distribution of exponents is possible. With the sum and the difference, we know that plus and minus do what to terms? They separate them. So therefore, we do not say that we can multiply the exponent where there's addition and subtraction. We can't do that. It's absolute nonsense to actually do that. So as long as we know the rules and the laws that apply to exponents, then we will always be winning, if you ask me. Then law number 4, a base raised to 0 is equal to 1, and we said the only exception is when the base is 0. If the base is 0, then we know that it is not equal to 1. But as long as the base is not 0, any base raised to the power 0 is equal to 1. But what's important here is that this 0 as an exponent needs to be above the entire thing in order for it to be 1. So for instance, 5 to the power 0 is a positive, value. So therefore we say 5 to the power 0 is equal to 1. Negative 5 to the power 0, the exponent is above just the 5. The negative 1, the negative here acts as a different base with 1, negative 1 times positive 5 to the power 0. So therefore our answer is negative 1. Okay, because the exponent applies to the 0 and not necessarily to the sign. Here, because there's a bracket around negative 5, the exponent is applied to the entire thing. So therefore, when you apply the 0 exponent to the entire negative 5, that leads to a positive 1 as an answer. Why is this positive 1? And why is this answer negative 1? The reason is because here, like I said, the 0 exponent only applies to the numerical value 5, not necessarily to what? To the negative sign. Okay? Here, the 0 exponent applies both to the sign and to the numerical value because it is inside a bracket. This 0 is outside, and this 0 applies to everything inside the bracket. So that's why here the answer is positive 1, opposed to here the answer being negative 1. Okay. Remember, 0 is an even number. So whenever you apply an even number or an even exponent to a negative sign, what happens to the sign? It becomes positive. So these are things that are so important. Like, these are basic things. But you see, this is the funny thing. This is what separates a top student and a top student that gets mediocre marks, because they are aware of these minute little things that will affect calculations or simplification when the need arises. Okay. Then we looked at negative exponents and the fact that any base raised to a negative exponent simply means that that particular base will change its position. Okay, so it's currently the x is in the numerator. So when you apply the negative exponent, the variable x changes position from the numerator. It is written in the denominator. The sign of the exponent changes from negative to positive, and then our answer becomes 1 over x to the power n. Why 1? Because there was a 1 multiplied to the variable x. That's why it becomes, the 1 gets left behind, the x leaves its position of being in the numerator, goes to the denominator, the exponent changes sign from negative to what? To positive. So that is why, for instance, we say x to the power negative 3 is actually equal to 1 over x to the power 3. Okay, so yeah, these are important things to note when dealing with exponents. All right, and so we also looked at the fact that a root, if you have a root, for instance, the mth root of x to the power n, remember that you can change the root from root form to exponential form. How? You simply remove the root, the mth root in this case, the n, the exponent, becomes your numerator value in your fraction, and then the m here, whatever the root is, becomes your denominator value in the rational exponent. So that's how you change a root form to an exponential form. Okay, and then something else to note just generally here, that whenever you have a fraction raised to the negative exponent, you can always write that particular fraction as the reciprocal. In other words, the numerator b, the denominator b becomes the numerator a becomes the denominator, and what happens to the exponent? The sign of the exponent changes from negative to positive. Okay, this is in conjunction with applying this particular law of a base raised to a negative exponent. You simply change the position of the numerator and the denominator, and then that allows you to change the negative exponent to a positive exponent. Okay, so now I think we're going to look at some problems, because we've looked at the laws, and I'm hoping that all of us, we are clear about the laws of exponents. As a grade 11 learner, you need to be clear about the laws of exponents, because exponents are very, very important for a grade 11 learner, also for you going towards grade 12 when you enter into that particular grade. So let's start with something very basic and simple, something very familiar and nice. So we are going to look at this very first problem, and you guys are going to apply your laws, and you are going to tell me in the comment section what the answer will be. So the first question, which is very basic, this obviously is just us applying the laws to see if we know our laws very well. P to the power 3 times p squared times p. Please guys, don't be scared to send me your daily hot me. Send me a rose when you need to or you want. Send me anything just to show your sense of presence here. But I like the fact that you are commenting in the comment section as well. Please do double tap on the screen, like the live, so that we can get more people coming into this live. Terry23 says p to the power 6. User 0382 says p to the power 5. So guys, let me tell you this. There are what we call exponential ghosts that exist in exponents. We call them exponential ghosts. Okay, you guys know Ghost Klubi, right? Yeah. Well, I think he has a video there where he actually had people go in a frenzy in one of these live, what you might call these videos he usually does. But I will call these ghost exponents. All right, ghost exponents. So for instance, someone who said p to the power 5, it just means that they can't see the ghost. Okay, the hiding ghost. There it is, guys. There is a 1 that is there, that exists for p to the power 1. So if you write the answer here, we apply law number 1. When we are multiplying same bases, p, the bases are the same. What do? We keep the base, we add the exponent. So let's be very careful with the ghost exponent, right? It was initially not there, and if we do not see it, then it's very easy for us to think that it's not there. So 3 plus 2 plus 1, that's simple addition. That gives us p to the power what? P to the power 6. So those who said p to the power 6, here you go. Hope you received that beautiful kiss. All right, good job, guys, good job. Okay, next, number 2, right? 5x squared times negative 3x to the power 4. Guys, we're just getting into the groove. We're trying to get our groove, in there, right? So please use the comment section. 5x squared minus 3x to the power 4 is equal to what, guys? Okay, we're just trying to get warmed up, because we want to also know that we know the laws, we know how to apply the laws and all of those things. Okay, Tlohit D just came in, already giving me answers. Negative 15x to the power 6, going once, going twice. Okay, it seems like we have got a consensus, right? So majority of the people are saying the answer there is negative 15x to the power 6. Okay, Pasha is saying the same as well. All right, it seems like we have a consensus. So of course, what are we doing here? Initially here, we were just multiplying variables. Okay. All right. And the variables that were the same base variables, we were multiplying same base variables. So it was easy for us to say p to the power 3 times p squared times p to the power 1 is equal to what? P to the power, we use law number 1. Law number 1 says when we have the same bases, we keep the base, we add the exponent. So now we are here. Here, we don't only have variable bases, but we have also numerical bases. We have numerical bases with variable bases. Okay, so this is very important to note. So as we multiply, we take into consideration the fact that we've got a sign, we've got a number, we've got a letter. Hopefully during this holiday, guys, you are staying very far away from these kinds of movies. Sign, number, letter movies. These are very, very dangerous movies. You don't want to be wasting your time deteriorating your mind watching these movies. SNL, right? Especially when they have the 18 and they have all sorts of things. So what we rather want to do is we want to focus on exponents, and whenever we're multiplying exponents or dividing exponents, multiplying exponents, dividing exponents, multiplying exponents, dividing exponents, we want to always remember that we multiply the sign first, we multiply the numbers next, and then we multiply the what? The variables or the letters next. Make sense? So when we come here, we need to first multiply what? The sign. That's our focus first. So we need to, when we are dealing with exponents, also not forget the laws that have to do with our signs, right? Now, we have a positive 5x squared and we have a negative 3x to the power 4. So what is a negative times a positive? That simply gives us a negative. So that means our sign is taken care of. We've multiplied our signs, we got a negative. We move on to the next thing, the number. The number, the numerical base, which is 5 and 3. So the question is, what is 5 times 3? That gives us a whopping 15. So that means our number, numerical base, has been taken care of. We move on to the next thing, the letter. X squared and x to the power 4. That is our variable base. So what do? We multiply x squared times x to the power 4. What's x squared times x to the power 4? So now we think of law number 1 of exponents, which says what? If the bases are the same and we are multiplying, what do? We keep the base, then we do what to the exponents? We add them. So that means 2 plus 4. So our final answer, as has been said by many that came into the live before, is negative 15x to the power 6. And particular detail was taken care of when answering this question, because we considered what? The sign, then the number, then the letter. This is very, very important. Okay, right. Hopefully, when dealing with multiplication and division, and I repeat, when dealing with multiplication and division, we never forget who? S, N, L. We multiply the signs, we multiply the numbers, we multiply the letters, and then voila, answer comes to pass. Okay, number 3, we're moving on. Very nice. 7a to the power 4 times 2a to the power negative 2, 2a to the power 2 times 2b to the power 2. Okay, sorry guys, that's not a negative sign, right? That is a positive 2. Let me just put that positive there. Okay guys, please help me out. I just want to know what is the prevailing answer there. 7a to the power 4 times 2a to the power 2 times 2b to the power 2. What is your answer? You can comment in the comment section. And whilst you are at it, you can send me your daily heart me. You can double tap on the screen. You can send a flower. You can send a ice cream. It is very hot outside, guys. You can do all that needs to be done and make sure that it is lively in the comment section. Okay. Amy Rose, add the exponents. Well, besides just add the exponents, there's more to this particular question than just the exponents, Amy Rose. Hopefully you can see that we have 7a to the power 4. This is a numerical base. Okay. Yes, multiply the coefficients. Okay. All right, you see. So let's make sure that we have all these things intact. Ms. Zim says 38a to the power 6, b to the power 2. That is Mrs. Zim's answer. Thank you, Ms. Zim, for your response in the comment section. Much appreciated. 38. No, it's wrong, Ms. Zim says. Okay, Ms. Zim, well, I await your correct response in the comment section because you are the only one that has basically commented with a specific answer. I think others are watching on very nicely to see what is going to be the result. The relationship between 7a, 2a to the power 2 and 2b squared is one of multiplication. So once again, we are dealing with multiplication of what? 7, 2, 2, which are all positive, positive, positive. So we have to then look at the sign and the number that are there, the coefficients, the numerical coefficient bases that are there. Multiply the sign, multiply the number. Then we have letters as well. A to the power 4, a squared, b squared. These bases, a to the power 4 and a squared, are the same, whereas b squared is different. So then what do? We multiply. Okay, firstly, the sign. 7 is positive, 2 is positive, 2 is positive. What's a positive times a positive times a positive? If we are considering the multiplication of the sign, then of course we know that is a positive answer. Numbers. 7 times 2, we know that is 14. 14 times 2, yes, Miss Zim, it is 28. So for your numerical number base, you are 100% correct. The answer is 28. So our sign and our number gives us positive 28. The only thing that's left now is to multiply the what? Our letters. A to the power 4 times a to the power 2 times b squared. So a to the power 4 and a to the power 2 have the same base. So the law of exponents says what with the same bases? Whenever we're multiplying same bases, what do? We keep the base, we add Mr. Exponent. So 4 plus 2. B squared, on the other hand, is a different base. So we write it next to what we have for A as a separate base, b to the power 2. Right? Then our final answer, we add, guys. So our final answer is 28a to the power 6, b to the power 2. How easy, guys. Applying law number 1 of exponents, taking into consideration our sign, number, and letter. S and L. What a good way to look at these letters once again, guys. Remember, like I said, let us avoid the movies that have S and L and focus more on the mathematics of S and L, meaning multiplication of sign, multiplication of number, and multiplication of letter. Amen. Okay, let's look at another question. 3b squared q times 2p q squared. Guys, these are, yes, fundamentally the basics. And I know some of you are like screaming, like, come on, dude, can't you just do difficult examples? No, I won't. Okay, I need to get basics through. We are focusing on basics. Okay, 3p squared q times 2p q squared. Right? So once again, what is the relationship between this and that? We have a multiplication relationship. So if there's a multiplication relationship, then it means what are we multiplying? Okay, we are multiplying a numerical base and we are multiplying variable bases. All right. It is indeed Christmas, Mangele, it is Christmas, Christmas, which is why Santa Claus has decided to actually hide himself and be a mathematician, a maths teacher that can help you with your maths woes. Okay, so Smangele, you can either Smangele or you can Smangele out of here. All right, so it's up to you really. Okay, 3p squared q times 2p q squared. All right, 3p squared q times 2p q squared. Guys, what are we going to do here? We know we are dealing with what? With multiplication. That's the relationship between the bases. Then what do? S, N, L. Sign, multiply the sign. 3 is positive, 2 is positive. So we multiply the sign. Positive times a positive gives us a positive. Remember guys, a positive sign can remain invisible, as you can see here, or we can make it appear, right? So as long as we have one term, it can just remain invisible, the positive sign, okay? Then we move on to the number 3 times 2. What's 3 times 2, guys? Let's see in the comment section if you guys know what 3 times 2 is. You'd be shocked at what people can say about 3 times 2. You would think people know what 3 times 2 is, but you'll be shocked at the answers that people give you when you ask them what 3 times 2 is. Miss Sim, like, man, Miss Sim is like, yeah, Miss Sim is so proactive in the comment section. Thank you, Miss Sim. 100% correct. It is 6. Then we move on to the letter. We look at same bases, p squared and p. Yeah, Katleho, that's what I mean. 3 times 3 is equal to 6. That's exactly the point. That is the point. Sometimes people tell you such things, and then you have to, like, you have to be sane when people tell you such. I'm telling you. I know, Miss Simi. Katleho knows that 3 times 3 is 9, but it's just that people will say funny things like that. That's what I think Katleho, the point is trying to make there. Okay, p squared, because sometimes 3 times 2 becomes 5, That's when the brain just does not operate very nicely for us. P squared times p. Remember, guys, I said that there are ghost exponents here. So, for instance, p has an imaginary hidden ghost there, and we know what is actually there as an exponent for p that we do not see. Because sometimes, because we don't see that, we fail to do what? To add that exponent. Thank you, No Pinky. No Pinky, No Pinky. Yes, No Pinky. It's p to the power 1. So here we say p to the power 2 plus 1. We add that hidden exponent. What about q? Look at q as well, okay? So we add the exponents for base p alone because it is the same base for p alone. So we add those exponents. We collect exponents for same bases. Q and q squared. We write q alone and then we collect its exponents by adding the exponents because we are multiplying same bases. So once again, what is there that we don't see for q? What exponent is hidden there for q? Yabo? You see this thing? I hope you guys are understanding. So there again, we have 1, the ghost exponent, 1. 1 plus 2. So that then gives us a beautiful final answer of 6p cubed plus yeah, I know. Didn't I just get all of you? Imagine such nonsense. 6p cubed. That is our beautiful sweet answer for that particular question. All right, so I hope you guys are flowing with me here. Please, guys, continue to like the live. We are on 2.3k likes. Thank you so much for those. I really appreciate it as well. Double tap the screen as much as you possibly can. Do send a beautiful, nice support for the live creator. It really means a lot. When you guys when you send these, sort of like surprise gifts, they really mean a lot. It's not like we don't like them. We love them when they do come. Okay. Angela, thank you so much for pointing it out. I think like majority of the people here, they rested overnight. If there are 113 people here, Angela, it must mean that it is good for them to be here. Maybe it is also good for you to join us if you want, but if you don't want, you can always go rest, my dear. We don't want to be stressing you being here, Hi, April. 5. All right. So next question. X to the power 9 over x to the power 5. Now we are moving, guys. We were dealing a lot with the addition of exponents. The life of STG. Hi, the life of STG. Okay. X to the power 9 over x to the power 5. Okay. What does this line mean? This one. This fraction line means what, guys? If we look at our operations. What does this line mean? Thank you, Ms. Zim. It means division. So what are we doing actually here? Now we are dividing what? Same bases. So when we divide same bases, what does the law say? The law of exponents says when we are dividing same bases, we keep the base. What do we do to the exponent? Someone tell me in the comment section. What do we do to the exponents when we are dividing same bases? What do we do to the exponents, my dear amazing people there in the comment section? What do we do there? We keep the base, then we... Thank you, no Pinky, no Pinky, no Pinky, no Pinky. No Pinky is so pink right now. So pink with happiness. We subtract the exponents. Yes, Tabang, we minus. Amen. Hallelujah. 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 Hallelujah, my people. Right? So the thing here that we need to note, if you remember, okay, the x to the power 9 that you see there, right, it gets joined by x to the power 5. X to the power 5 changes position from the numerator, from the denominator, goes to the numerator, and what happens to the sign of the exponent for 5? It changes from positive to negative because this x to the power 5 changed position. Guys, this would be like me saying, if I rewrite this, I could write it as x to the power 9 times x to the power negative 5. Does that make sense? Because this x to the power 5, if we look at the definition of exponents, this x to the power 5 is in the denominator. It moves to the numerator. What happens to the base of x? It moves to the numerator, then the exponent changes from positive to what? To negative. And now obviously the relationship between the x's is no longer divide, but it is multiply. Okay, this would be another way of just sort of like interpreting what has just happened here. So it is well to subtract that exponent in the numerator. All right, x to the power negative 9 minus 5. 9 minus 5 gives us x to the power what? Very good, April. April, with that check mark that you have for your name, that is the correct answer, my dear. X to the power 4. Just like your name says, I would do the same thing, April. April C, and then boom, with that correct sign there to show that, hey, Wena, you are amazing, April. You are amazing, April. In December, April. You know? AKA Jeezy, maybe you can just send me a gift there. I see you are a level 1 gifter. Just send me a rose there to show that it is truly December. If you can send me 10 roses, let me say, if you send me a galaxy, aka Jeezy, I will stop this live, I will end it, and then I'll allow the people to go back to December vibing. Send me a galaxy and then I will stop the live, I promise you. AKA Jeezy, since you are so adamant that it is December, I will stop the live. Send me a galaxy there. Just send me one galaxy, my friend. I'll stop. I promise I'll stop. I'll end the live now. Thank you for the rose, by the way, aka Jeezy. It is December, boss. Get December, boss. That's why we need to make sure that we store up and prepare very well, so that when January comes, we can kill the academics. I will be academic warriors, you know. Yeah. Okay, number 6. A to the power 3, B to the power 8, A to the power 2, B to the power 5. Guys, please don't be scared to send me gifts. I feel like some of you are scared to send me gifts. I know you guys send big gifts in other live streamers that are not even teaching maths, and they have a hell of a good time because you guys are sending them gifts, but you are not making it popular for academic, educational live sessions like this to become gift oriented. Because I don't know why. Come on, guys. Come on. A to the power 3, B to the power 8 times B to the power 8 over A squared, B to the power 5. All right. How do we go about this? A to the power 3, B to the... Thank you so much. Luandle and Gobes and Tloche. I know these people know their stuff. aka Cheesy. You should have helped me. I got 3 out of 150 in metric. Hi man. Hey, that is very, very sad. I'm sorry, my friend there. Thank you, Miss Zim. Very good. No pingy there. AB to the power 3. Very good. We do the same as number 5. Yes, April. All right. So once again, the relationship between A and B in the numerator is multiplication, division, multiplication. So guys, as long as there's multiplication and division, the laws can be freely applied. When there's multiplication and division, laws can be freely applied. So we look at the relationship and we freely apply the laws. So a to the power 3 over a to the power 2, because the multiplication is there in the numerator and then the denominator, guys, you know, that's what combines a to the power 3 and b to the power 8. It's multiply. And then the line means divide. So we can then apply law number a to the power 3 minus 2, b to the power 8 minus 5. Finally, this is a b to the power 3. The person who's asking, but sir, where is the 1? Where is the 1, the exponent 1? Remember guys, as long as the variable is there, the exponent 1 remains as a ghost. It is there as well. Okay? Which is fine. That's our answer, guys. Nice? Okay. 7. If you are stuck somewhere, you have the obligation to stop me and say, I am stuck. I don't understand what you just did. Okay? You must do that. Use the comment section and harass me and stop me and say, I don't understand. 3x cubed y squared times negative 2x to the power 4y to the power 4 times 2x squared. Yes, I know my x's kind of look like my multiplication signs. Yes, guys, this is x the letter, this is multiplication, this is x the letter, this is x the letter, and that is multiplication. Okay, Pretty says, can we go back to number 6? Pretty, we are here back at number 6. A to the power 3, b to the power 8 over a squared, b to the power 5. The relationship between this a and this b is multiply. That's what combines these two together. They become 1. This line means divide. This is a squared, b to the power 5. What combines a squared and b to the power 5? It's multiply. Are we together? So all in all, to solve this particular or simplify this expression, we have a to the power 3. In the denominator, we have a to the power 2. The bases are the same. All right? The relationship between the bases, all of them, is multiply and divide. So we are then freely allowed to apply the laws of exponent. The laws of exponent apply freely when there's a relationship of multiply and divide between our bases. So then we look at the same bases. A to the power 3 and a to the power 2 are same bases. We are dividing. The relationship between a and this a squared is one of division. So what do we do when we are dividing same bases? We keep the base a because it is the same. We subtract the exponent. 3 minus 2. All right? Then we move on to the next variable, b. B to the power 8 and b to the power 5. What do we do when you are dividing same bases, b to the power 8 and b to the power 5? We keep the base b. Then what do we do to the exponents? We subtract 8 minus 5. Then we write our final answer. What's 3 minus 2? It is 1. What's 8 minus 5? It is 3. So that is why ultimately we can actually write the answer as ab to the power 3. This a, which has a 1 exponent, this is a ghost invisible. We can write it as an invisible ghost. We can write it there, whether we write it or not. That means the 1 is there. User 1655, it's December. Let's enjoy. Then we shall see math later. Guys, have you ever seen those friends that launch you? The friends that launch you. Like in this guy, when I read the comment, it's December, let's enjoy. It's like the YOLO mentality of like, no, let's drink and drink and drink. We will, doesn't matter. Or someone who wants to lose weight like big time and they really want to just like maintain a certain body size, they're like, let's just eat. Just eat, man. Eat all the meat you want. And don't worry about diet. We'll worry about it when we have New Year's resolution next year. Guys, dangerous mindset, that one. Dangerous mentality. Okay, anyways, let's go on. I hope that's clarified for those learners there. Okay, 3x cubed y squared times negative 2x to the power 4. All right, y to the power 4 times 2x to the power 5. All right, so let's deal with this. First and foremost, what is the relationship between these bases? Number base, variable base, variable base. Combined times this one is negative times this one 2x to the power 5. So the relationship that exists here, guys, is one of multiplication. Okay, multiplication. So what do? The relationship is one of multiplication. I said to you, we take care of the sign. We multiply the signs first. We move on to the number. We multiply the numbers next. We multiply the letter. Remember, SNL. Positive times a negative times a positive. You see? So now we need to first take care of the signs. What's a positive times a negative times a positive? That gives us a what? Guys, you know what a positive times a negative is? It is negative. Then a negative times another positive, that gives us a negative. So it's a negative sign that we have. Sign has been taken care of. We move on to the number. Numbers. 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. So therefore our number is 12. But it is negative. Then we move on to what? To the letter. Which letter? The letter first that we are going to focus on is x. X to the power 3, x to the power 4, x to the power 5. We multiply these letters. X to the power 3 times x to the power 4 times x to the power 5. We keep the base x. We add the exponents. 3 plus 4 plus 5. 3 plus 4 plus 5? 3 plus 4 is 7. 7 plus 5 is 12. The exponent for x is 12. Then we move on to the letter y. We have y squared and y to the power 4. So we keep the base y. We add its exponents. 2 plus 4. What's 2 plus 4? It's 6. Is there anything else to be done? No. So our beautiful maths gamers there, Miss Zim and Nopingi, you were 100% correct in your answer. Pasha was 100%. Thank you so much, guys, for your response in the comment section. You guys were 100% spot on. Guys, do you see this thing? So when there's multiplication, we apply multiplication of sign, number, letter. Just put it in that order in your heads, guys. You multiply first the signs, you multiply next the numbers, you multiply next the letters. X, X, X. You multiply the letters Y, Y. You see, you combine them together. The reason why negative 12x to the power 12, y to the power 6 is written as a combined thing is because the relationship that combines things is multiply. Multiply combines. Divide also combines. That's why I'm saying multiply and divide are the perfect condition for us to be able to apply the laws of exponents. Thank you, April, for your question. Remember, 3 is positive. 2 is negative. This 2 is positive. So remember, April, I said you multiply first the signs. You establish that 1, 2, 3, all of these three are having a relationship of multiplication. So you say a positive 3 times a negative times a positive. What is a positive times a negative? It is negative. Then you times it by another positive. What is it? It is actually equal to a negative. That's where this negative sign comes from. Okay? Okay, then you move on to the number 3, 2, and 2. You multiply the numbers alone now. What's 3 times 2 times 2? That gives you the 12. That's where the 12 comes from. Then you go and multiply the last thing, the letters, the variables, the letters of the alphabet. X times x to the power 4 times x to the power 5. These are the same base x. So when you are multiplying same bases, the law of exponents says you keep the base x, you add the exponents. 3 plus 4 plus 5. What's 3 plus 4? It's 7. Plus 5, it's 12. That's where this 12 comes from. You move on to the next letter, y squared, and y to the power 4. You are multiplying them. So you keep the base y, you add the exponent. 2 plus 4 is 6. Final answer, negative 12, x to the power 12, y to the power 6. Amen. Thank you so much, guys, for the heart means. I saw my darling there, my darling sweetheart. The view. Thank you so much for the heart me there. I see some of you are getting into the groove of gifts. Guys, sending gifts really encourages me. So please don't be scared to send gifts, heart me's, and all of that stuff. Please, guys, don't be scared to do such. It is really supportive and helpful. Yeah, thank you so much. Next. P squared, Q over PQ squared. People who are asking what grade is this? This is as basic as grade 8. All right. This is as basic as grade 8. Grade 8s as well do exponents, guys. And this is grade 8 revision, right? But it's for grade 11s because grade 11s need to understand the basics from where they actually come from. Grade 8, 9, 10, 11, right? Yeah, this is a grade 11 exponents and third life, but it is going back to our grade 8 foundational laws of exponents. Okay, thank God I'm done with school, Mawoji. Mawoji is like, I'm done. Okay, 2p squared q, the whole thing to the power 2 over pq, the whole thing to the power 2. Yes, like I said, guys, if you are grade 8, 9, 10, 11, you 12, you are in the right place because these laws are very important for everyone. Yeah. What is this, bro? It's exponents. Okay, 2p squared q, the whole thing squared, over pq, the whole thing squared. Guys, what do we need to remember here? We need to remember who? Mr. Bad. B to the E to the D to the M to the A to the S. B means brackets. E means exponent. D means division. M means multiplication. A means addition. S means subtraction. Guys, you can't go anywhere in mathematics if you don't know bad maths. Okay, so you remember, you may have seen many people came into the live, they're like, go and rest. Where do they want you guys to rest? In a bed, right? Go and rest. Rest, guys. Rest in a bed. Okay? Right? The life of STG, I know you know board maths, but please listen to me. Listen to me very well. You see these things that I expose you to, I expose you to for a reason. Okay, so familiarize yourself to bed maths, all right? As a grade 8, 9, 10, 11, 12 learner, familiarize yourself with bed, okay? Just like you, most of you are waking up only now because you've been sleeping the whole, the whole day. Like some of you are still in your, what you might call, you are still in your 90s and in your pajamas. I promise you now, if I could have my camera zoom in and then I would project you on a big screen, I would see some of you are still in your pajamas, PJs. It's 3:28 in the afternoon, but you are still in your pajamas. Bed mess. Some of you haven't even taken a bath. Okay, you are still in your bed. So bed maths, right? Brackets, exponents, division. This is what I'm talking about here. So please, guys, you can't go anywhere without bed maths whenever you're dealing with simplification in mathematics, whether that be simplifying an expression, simplifying an equation, simplifying whatever. Bed maths is important. The order in which you operate is you need to first operate in a place where you first deal with the brackets, you then follow it up with the exponents, then you follow it up with the division if there is any, then multiplication, then addition, then subtraction. In that order, guys, in that order of priority. Okay, I hope you are with me here. So when we come here, in the numerator, okay, there in the numerator, why did I scratch myself? Because I don't want you guys to know. Chini, hey, Miss Sim, you are when, Miss Sim? Chini, let me continue. Scratch. Okay, 2b squared q, the whole thing to the power 2 over. When I'm Miss Sim, you are paying attention to things you ought not to pay attention to. Divided by PQ, the whole thing squared. So if you look at this, guys, you have in the numerator, let's focus on each. You have a numerator, there's a bracket, there's an exponent. The relationship between these bases, 2p and q, is one of multiplication. So you have a law then, a very good law. Okay, a very good law. Grade 12, I'll go live for you guys 9 p.m. tonight. You must come at night. I'm gonna see if I can't cross night for you, so that all these people that are wanting to go and drink and stuff because they are having New Year's, whatever, Christmas Eve vibes in their heads, you can either choose to be here or you can choose to go there. Grade 12, sequence and series. Let's meet later at night. Yeah. So 2p squared q, the whole thing squared. You want to apply for this bracket alone. You apply the exponent. Apply the exponent in the numerator, guys. Apply it. Okay. When you apply the exponent, remember you can only apply it where there's a relationship of multiplication between the bases, which actually exists here. Okay. The relationship of multiplication exists there. I want to go back to what I said to you when I did the laws. I said to you, law number 3, a base raised to an exponent raised to another exponent. You simply simplify this by multiplying. You multiply the exponent for that particular base. Does that make sense? So if you come here now, the relationship between the a to the power m and the b to the power n is one of multiplication. So law number 3, where the exponent is, you can apply the exponent, multiply a to the power m times this p, b to the power n times this p. That is allowed where the relationship between the bases is multiply. Look at this here. The relationship between these bases is division. There's an exponent outside. You can apply the exponent. You can apply law number 3 and multiply so that you have a to the power m times p over b to the power n times p. But guys, I said yesterday, we do not apply law number 3 where there is addition of bases and subtraction of bases. It is absolute nonsense to then say we can multiply the exponents where there's addition between the bases and where there is subtraction between the bases. We do not do that where there's addition and subtraction between the bases. We don't do that because these are separate terms. Plus and minus separate the terms, so you cannot apply the exponent there. So if we come here, conditions are good to apply law number 3. So simply put, we can do this. This exponent needs to be applied to the sign if there is one, to the number if there's another, and to the letter if there is as well. You apply the exponent to the sign, the number, and the letter if you have these available, because the relationship between the bases is multiplying. Yes, link is in my bio, Daylight 40, the YouTube channel there. Okay, so 2. We say 2 to the power what? 2 to the power, there's a 1 there, Moss. You know, Mr. Ghost. So we say 1 times 2. That gives us 2 to the power 2. Does that make sense, guys? We apply the exponent there as well. It's p to the power. 2 times 2. That's p to the power 4, guys. We go to the q. Q to the power 1. 1 times 2. That's q to the power 2. You see? Over. Let's do the same thing. There's an exponent in the denominator. You have pq, you have an exponent. You apply the exponent to the p. What do you get? You get p to the power what? 1 times 2 gives you p to the power 2. Does that make sense, guys? Then you have q. There's also a ghost exponent there, which is 1. So you say 1 times 2. That's q to the power what? 2 as well. Did you see how we applied this law? Law number 3 for multiplication of bases inside the bracket. We simply multiplied the exponent for the respective bases because the relationship is one of multiplication. Okay, does that make sense, guys? I hope it makes sense, because if it does not make sense, then that becomes a problem. If it doesn't make sense, it must be senseful. Thank you, Mr. Sean. Really appreciate it. Mr. Sean Martina, really appreciate that compliment there in the comment section. 2 squared. Now we can simplify. What's 2 squared, guys? That's 4. P to the power 4 q squared over p squared q squared. We are not done. We are not done. Now that we have dealt with the brackets and the exponents, okay, does that make sense? Now that we have dealt with the brackets and the exponents, we can now proceed and move on to the next line of what? Of operation. Okay, does that make sense? After we've dealt with the brackets and the exponents, because we are dealing with the bed, Moss. You are lying there, Moss, when you are still lying there in that bed. You don't want to get up and write down the notes. You're still lying there in the brackets, exponents, division. You are lying there having a good time, still wearing your PJs and all of that stuff. Brackets, exponents, division. Did you see that? Brackets applied the exponent. I could apply the exponents because law number 3 allows me to. Relationship between 2, the p, and the q is multiply. Bracket exponent can apply the exponent to the what? To the bracket, because the relationship between the p and the q is multiply. So b and e have been taken care of. Now I move on. What do I now have? A state of division. Does that make sense? Miss Zim, your comment, Shooty, happy birthday, Beyonce. Oh man, that's a funny one. Oh my soul. Oh my goodness, this comment. This one is the your schools are closed, my brother. That's what my good Lira said there. And Miss Zim. Miss Zim. Jonga, you've made my. This is Miss Zim's response. So what must happen now? Shooty, happy birthday. You guys kill me in the comment section. Sorry, you guys are hilarious. Too hilarious. Okay, brackets, exponents, division. Now we are here, guys. We dealt with B and E. B has been taken care of. E, exponents, has been taken care of. We used law number 3 to take care of that. Now division must happen. Do you see that, guys? The order in which we operate. So we now divide. 4p to the power 4, q squared over p squared, q to the power 2. So now when we deal with the division, we apply, we don't forget who. Who don't we forget, guys? We must not forget this, guys. S, who's S? The sign. We divide the sign. So this is a positive 4, this is a positive p squared, q squared. Remember, there's a 1 that we don't see there. It's there, but we don't see it. So 4 divided by 1, in that numerator, 4 is the answer. Okay, so the sign, positive divided by positive, is positive. Then move on to the number. 4 divided by, there's a 1 that we don't see there. What's 4 divided by 1? It is 4. The sign has been taken care of. The number has been taken care of. Now we move on to the letter. We divide same base letters, guys. What's p to the power 4 divided by p squared? P to the power 4 divided by p to the power 2. P to the power 4 minus 2. 2 joins the 4. Subtract, because when bases are the same and we are dividing, what do we do to the exponents? We subtract the exponents, my good people. Then we move on to the next letter, which is Q. Same base Q. We look for the friend in the denominator that has the same base, which is the other Q. So we say Q to the power 2 minus 2. Do you see, guys? Hey, hey. Hey, hey. Justin, Shruti, what must I do about that? Shruti, happy birthday, Beyonce. Aye, all of you just receive happy birthday, Beyonce, guys. Happy birthday, Beyonce. Happy Merry Christmas to you, Beyonce. 4p to the power 4 minus 2. That gives us an answer of 4p squared. Right? Because 4 minus 2 is 2. Then lastly, 2 minus 2. Q to the power 0. But remember, guys, we know something about when a base is raised to the power 0. What do we know when a base is raised to the power 0? Any base raised to the power 0 is equal to what? Let's not forget that. Very important definition we tend to forget. Okay, does that make sense? Yeah, because guys, all of what we're doing goes back to the laws that we've covered. We've covered the laws. Now we are just applying what we know, because we want to make sure that the laws, we understand how to apply them. You see? So now, q to the power 0. Remember, this 4 and this p and this q have a relationship of multiplication. So what you must understand is that 4p squared, this here, this p squared and this q, that gives us q to the power 0 is 1. It is 1. And rightfully so. What am I doing here? I'm putting it in brackets, because brackets mean multiply in maths as well. Right? Or you could actually say 4p squared times 1 if you want to. I mean, that's another way of writing the same thing. And then your final answer. Remember, what's 4p squared times 1, or 4p squared times 1? That gives us an answer of 4p squared. The q has gone. That is our answer. Now I need people who are asking questions to ask their questions. This is one way of doing this question. One way of doing this question. Okay, someone else who's looking at this may be looking at this and be like, sir, I have another way of doing it. And if you do, it means you, my friend, you are well versed in mathematics. That's why you can see many ways. What I'm doing here is I'm trying to get through to my brothers and sisters that seem to really struggle with just the fundamental basics. That's what I'm doing here. So if you're looking at this and you're like, sir, I know of another way, then great. And it leads me to the same answer, say, great, even better, right? I'm proud of you. You are phenomenal. All right? You're phenomenal. Okay. Are we together here, guys? Can I move on? This is clear for us. Bed mess. Bed. B-E-D. Brackets, exponents, division. That's all I incorporated when I was dealing with this. The minute I get to multiplication, I don't forget S and L. The minute I get to division, I don't forget S and L. Because when I'm dividing, I'm always going to be dividing a sign, a number, and a letter. When I'm multiplying, I'm going to be multiplying a sign, a number, a letter. You see? Yeah. So, I hope you guys are worth my here, you know? Like, it's so important here, you know? Yeah. So, let me move on to the next, problem, Okay. Daylight 40. What is the difference between bed mess and board mess? Board mess is what you guys utilized in grades before, like before grade 8. You guys looked at, or let me say, you did board mess, and there was something that it meant to you, right? Okay. There's something that it meant for you when you did board mess. Brackets, and you said off, division, sign, division, multiplication, addition, subtraction. All right. But it's just that when you get to grade 8, 9, 10, 11, you know, we usually come and we say, guys, board mess, very sweet and good, but let us come now and talk about bed mess. All right. Yeah. So in our order of operation, we just consider brackets, which is first priority, then exponents. Then we consider division, then multiplication, then addition, then subtraction. All right. Okay. All right. So minus 3ab to the power 2. Okay. And then there's another bracket. 2a squared b. Oh, my soul. All right, guys. Okay. No, it's fine. It's okay, Mr. Scam. Minus 3ab, the whole thing to the power 2, brackets 2a squared b, the whole thing to the power 3. So now we just want to simplify this thing. Okay, this is for all grades, grade 8, 9, 10, 11, 12. 1D the gamer. User 91. User 91 is the same guy who said Thank you. I see the Abby Viviana, fellow maths tutor here, been here for 2 minutes. You, sir, are a wonderful teacher. Thank you so much. Really appreciate that. That's sweet. Thank you so much. Thank you, guys. Thank you for the taps, guys. Thank you. We got into 12.2k likes. You guys are amazing. Please, guys, don't be afraid to send me or daily hot me there, and yeah, any gift is welcome and appreciated, you know, when it does come. I do have a live goal there. I'm sure you guys can see my live goal there. Please don't be scared to live goal me up. I really appreciate that. It means a lot when it does happen. It means a ton of a lot. Please don't be scared. Thank you, Eva Zoe. Really appreciate that. Thank you so much. One day the game, I say I've passed my mathematics because of you. No. One day the gamer, I basically have accepted that I cannot be to blame for anyone that passes maths. Anyone that passes maths, guys, passes maths because, do you know why? Do you guys know why people pass maths? They pass maths because they commit to it. I'm convinced. Guys, if people were passing maths because of me, I promise you now, I know what I do when I teach maths. But if everyone under the sound of my voice passed maths the way that I teach it, then I would say, then it's my fault. you can blame me for people doing well in mathematics, but no, it has nothing to do with me. It has to do with the attitude that you have, which is what I appreciate. So thank you so much, because it means that whatever you are doing in your corner, you are doing it well. Me, I am not doing it. You are the one doing it. Right? So thank you so much for the compliment, but I really mean from the bottom of my heart, you guys, the one that does well in maths, they are to blame. Okay, my learners know even at school, I can never be the one that is to blame for your good maths performance or your terrible maths performance. No ways, Jose. Chloride, I got 90% for term 1 because of you, and other terms I didn't watch you and I got level 6. It shows. Nah, something must have changed. You must reflect. I call upon you to spend some time alone and reflect and really search your heart and actually figure out what it is that changed with you. Not because you did not come to the live session. It has nothing to do with that. Once you tap into what I'm saying, then you'll begin to understand that it has everything to do with you. It's your fault. It's your fault. What is Grace saying? So how often do you go live? Grace, I go live. There's no set program or set structure, unfortunately, because my schedule becomes, that's why I can't even set a particular schedule whereby I'm saying I'll be live this time, because the thing is, I'm in a very dynamic environment. So unfortunately, I cannot say when. So you guys just need to make sure that you click the right things, you click the right things to ensure that when I do go live, you get the notification that I'm live. That's the unfortunate thing, okay? Right, let's go on. Juicy, let's continue. Juicy wanted my account, my bank account detail. I'm gonna send you my bank account details, Juicy. It seems like there's something juicy that you'd like to send to me. All right, minus 3ab, the whole thing to the power 2. Brackets 2a squared b, the whole thing to the power 3. Okay, let's take it one step at a time. Remember, what did we say, guys? We said get out of the bed. Didn't we say so? Bed mass. Brackets. So firstly, let's look at this bracket alone and then look at this bracket alone. Brackets. Then look at each bracket and apply its exponent. Is it allowed? Can we apply the exponent to this bracket? Yes. Why? Because the relationship between the negative 3ab is one of multiplication. So the bracket can be the exponent can be applied to the bracket, because the relationship that exists between the numerical coefficient, the variable a, the variable b is one of multiplication. That's what combines these two things, these things together. So let's apply the exponent. An even exponent applied to a negative sign. Guys, very important. A even exponent applied to a negative sign leads us to a what? A positive answer. These are things that we need to know. A even exponent, this number 2, the exponent is even. So if the exponent is even and we apply it to a negative sign, that means the negative sign becomes positive. Hey guys, I hope you are listening to this. When you apply a even exponent to a what? To a negative sign, what happens to the negative sign? It changes. Even. All right, guys, the exponent has to be even for us to have the sign change. But if the exponent was odd and it was applied to the negative sign, that negative sign would stay as it is. Does that make sense, guys? I hope you are listening to me and you're listening to me very well. So any even exponent applied to a negative sign leads to a positive answer. But if the sign is negative, if the exponent is odd and it is applied to a negative sign, that sign stays the same. In other words, an odd exponent does not change the sign. Okay, does that make sense, guys? Yes, Tloghi. It's only if the exponent is outside. Please, because here's the difference. If I said to you, what is negative 1 squared? And what is negative 1, the whole thing squared? There is a difference. This exponent here is applied to the 1, not to the sign. But this exponent here, because of the bracket, means that the exponent is applied as well to the sign. Okay? So here the answer would be negative 1, whereas here the answer would be positive 1. What a difference in our answer. Does that make sense, guys? Hey. These are basics, guys, that I'm telling you. Do you know that these basics are basics that are not basic? It's common sense that's not common. And it's one of those things that irritates the living daylights out of me, even for students that do very well in maths, but they mess up things like this, basic things like this, because they don't have basics down. You guys need to have the basics down. Okay, so let's apply the even exponent to what? To the sign, the number, the letter. We apply the even exponent to the sign. So if we apply to the sign, then we have a positive answer. We apply the even exponent to the number, we have 3 to the power 1 times 2, which is 2. We apply the even exponent to that letter, we have a squared. We apply that even exponent to the other letter, we have b squared. So do you see what happens? We remove the bracket by applying the exponent to the sign, the number, and the letters. Then we move on now. We are done with this bracket. We move on to this bracket. There's an odd exponent. We apply that odd exponent to the sign of the number, the number, and the letters. Let's do that. Remember, brackets in maths, brackets mean multiply. So the relationship between this and that is one of multiplication. So I can go ahead and just say multiply. We apply the exponent. Thank you, Candy. You're awesome too. Thank you. Woo! Candy, you are making me happy. Thank you so much. Those you awesomes are like, yo, they are heartfelt. Candy! Woo! Candy with the friendship necklace. Woo! Yeah, that's what I'm talking about. Okay, let's apply the exponent now to the sign, the number, the letter. Let's go. So we have 2 to the power what? 3, guys. Okay, 2 to the power 3. Then, because remember, this is 1, there's a 1 there, but 1 times 3. Remember, law number 3 of exponents, this law, this one. We are applying this law, guys, this one. That's what we are doing. A to the power m times p, b to the power n times p. Does that make sense? So we are applying that law. 2 to the power 1 times 3 is 3. A to the power 2 times 3. Let me just write it out there. Then b to the power 1 times 3. Okay? I hope you're understanding, guys. Okay? Then, hey, we have 9a squared b squared times 2 to the power 3 is 8. A to the power 6, b to the power 3. Okay, so it's coming together very nicely, right? Then we finally wrap it up. We multiply now because we dealt with brackets, exponent, there is no division, so we skip, we go to multiplication. See, when we applied the exponent there, we considered applying the exponent to the sign, to the number, to the letters, to the sign, to the numbers, to the letters. Then after that, D, no division. We move on to the next thing, multiplication. And remember, as we apply multiplication, we consider as we multiply the what? The sign, the number, the letter. Guys, SNL is playing its role. Maybe that's why we had to see SNL so many times when we were young, and so many times we see it in the TV screen. It is not so much that we had to see that thing for those programs that we would watch or those movies that we'd watch, but because one day they knew that you would meet me, and then me, I would emphasize this thing that you first need to multiply the sign, then the number, then the letter. So There it is, guys. This is positive, that is positive. So a positive times a positive is positive. The sign is taken care of. It's positive. We move on to the number. 9 times 8 is 72. The number has been taken care of. Then we move on to the letter. Letter. A squared times a to the power 6. That's a to the power. Now, when we are multiplying same basis, what do we do to the exponents? We add the exponents. So it is 8. 2 plus 6 is 8. Then b, 2 plus 3 is 5. Amen. Oh, the diddler just followed me. Oh no. No, I'm very scared of the diddler. What in the world? The diddler has a profile picture and it's Durex. What in the world? This is so crazy. Diddler. Okay, so 72a to the power 8, b to the power 5. Beautifully done. Beautifully done. There it is, guys. 72a to the power 8, b to the power 5. Guys, that is that, man. Really and truly, like I don't know if you guys quite understand how important it is to know these basics. Okay, and guys, I'm done. I'm finished. It is 4 p.m. I'm done for today. Thank you so much for joining my live. It was amazing. All right, I'll definitely be coming in again tomorrow, continuing on in the same trend, guys, of exponents, just doing it one question at a time, unpacking the basics, because it's very important. Yes, Tlochidi, you have a question. What question do you have? Before I leave you and love you and see you and have fun with you another time. Yes, Tlochi, what is your question? What is your beloved dear question? Oh yeah, you've answered the question. Oh, I have, thank you. Woo! Oh man, I love this. Okay, guys, thank you so much. And Kenny D, thank you so much for the gifts. I really appreciate it. Like, I mean, yeah, guys, that's what I mean. Candy. Oh, it is candy. Ooh. Man, Candy sent me some candy, that's for sure. Thank you so much. Journey past, we have like 23 You Awesomes, 1 friendship necklace, and a 1 Jenny pass. Thank you so much, Candy. Really appreciate that support. It is much appreciated, more than you can know. Rati, I'll see you guys tonight at 9 p.m. my grade 12s. We will pick it up with sequence and series. All right. Funny thing is, so with my grade 9s, sorry, with my grade 12s, yeah. Can you do some for division line next? Rejoice, I'm done. I'm done for today. I'm done for now. So maybe I may go live in the next 20 minutes. Who knows? I don't know. We'll just see. Okay, we'll just see with how open the day is. I just need to make some food, some dijo, some food, so that I can actually also revitalize my organs and stuff. But yeah, guys, this is what we did today. We just did basics for exponents, you know, and we're gonna get complex, but we get complex after being basic. Okay, does that make sense, guys? If we do basics and basics become food, our stuff, then the complex problems are nothing, to be honest, guys. They are nothing. Like, they are nothing. Complex things, remember, complex comes from basic, right? You see a glorious mansion being built, and you get wowed by, wow, this mansion is so beautiful. You get into the house, like let's say Ghost Klubi's mansion. You go into Ghost Klubi's mansion, you get into that mansion, you get wowed because you are thinking now of that 2-room house, or that RDB house, or the whatever house you come from, and you look at that mansion, you're like, wow. But guys, what you don't get is the fact that that mansion was built brick, by brick and how basic a brick is, right? That's where it comes from. So the same way, you need to first establish the building blocks. The funny thing is, Exponents also lays a foundation for another topic for grade 12s that they do, which is called calculus. Now, if you don't know your exponents well, your exponents and sets, you're going to cry with calculus. You're going to say calculus is difficult. Calculus is simple, but it needs the basics. You need to know the basics well. Okay, make sense? So if you do that, then you'll be fine. Guys, grade 12s, you most likely will see you around 9 p.m. guys. 9 p.m, 8-ish. 8-ish, 9 p.m. Please, okay? Yes, Kochi. Yeah, exactly. Algebra is the foundation for all topics, or rather, most very true. Thank you so much, guys. I'll see you again. Thank you for your participation, for your availability. All those people that were here. Miss Zim, like, you were amazing. You made me laugh a lot. Like, happy birthday, Beyonce. And all of those things. Like, too much fun. Juicy, but you will teach us, Angisho. Teach us what, Juicy? Juicy, which grade are you in? You grade 12, when? Juicy has some juicy stuff that Juicy, I think your name is Juicy, too juicy for your own good. 12. Now we'll see you guys later on. Like I said, grade 12, we'll teach you grade 12. Sequence and series, we'll start with that. We'll take it up, all right? See you later, much later. And then you were not Juicy, you said you wanted my bank details as well. I'll send you those as well. We'll see what happens, what magic happens there. Okay, guys, cheerio, toodles, it was great. See you again. Grade 12s, we'll see you later on today. Like I said, around about 8-ish, 9-ish, if 10-ish, we'll see if we can't pull a all-nighter stuff and enjoy there. Cheers, guys. Love you. It was great. Amazing while it lasted. Yeah.